All right, so here's sample problem 2.7. It's a relatively long problem, but not too terribly difficult, but it's methodical, right? So let's take a look and work through it together. See what we're given. We know that the tension in this guy wire, that's like this guy right here, from A to B, is 2,500 newtons. So I'm going to write this down. F is 2,500 newtons. And we want to determine the components of Fx, Fy, and Fz of the force acting on the bolt at A. So by the way, acting on the bolt right here, right? So what we would like to, when we're done with this thing, right, we want to find a force that's coming up that way, right? Because that's the force acting on the bolt, right, due to the guide wire. We also want to find theta x, theta y, and theta z. So these are going to be the direction cosines, i.e. the direction angles. So what we want to do is we want to start out by finding the distances between here. So let's define them. Like, say, let's go dx is equal to x2 minus x1. So what is x2? x2 is actually going to be 0, right? Because this thing is right on. If this is x and this is y and this is z, we could see that x is really kind of coming boop, 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 that way right there, and it lands up on that line. So it's going to be 0 and then minus 40. So the answer is minus 40. And these are meters. And then we could take dy and say y2 minus y1. And so y2 is actually, it's up above, right? So it's going to be 80, but it started out at, we can presume that that's 0, right? It appears to be 0. So we know that it is going to be 80.00. I should have put another 0 up here, right? If I'm going to be consistent, about 4 sig figs for in between steps. dz is going to be z2 minus z1, which ends up being, let's see, z2 is, of course, that it looks like it's on the 0, and it starts off with 30 meters, right? So minus 30, so it's a minus 30 meters. So if we're going to rewrite that, what that vector would be, it would be all those things in a row right there. All we need to do is find the magnitude of this, right? So that's going to be dx squared plus dy squared. I might not even write this. No, I think it's good practice, right? So the square root of negative 40 doesn't need to be negative right here, right? 80 and the squared plus negative 30.00. Once again, we didn't need to write negative necessarily in there, and I don't think I did in my page here. 94.34 is the length, or not? Yeah, the overall length of this cable. So when we go to fx, we can find that by taking the magnitude times dx and dividing it by d, or 2,500, and then we could even put this over to the side, negative 40 over 94.34, and get a negative 1,060 newtons. Fy, similar. F dy over d equal 2,500, and that's going to be 80 divided by 94.34, and that's going to be 2,120 newtons. And then Fz is going to be F dz over d, 2,500, and negative 30.00 over 94.34, and we get a negative 795 newtons. So if we're going to write out our answer right here, well, it asked for the components, so that might have been the answer. I probably would say, give me the vector right here, because that's going to be really the thing we care about. Right? Yes, I want the components, but I would rather recall that this is the fully defined vector of that force. And make sure we give it units. So this is a fully defined answer. Continuing on with the part B of the thing, it wants to get theta x, theta y, and theta z. So we take the inverse cosine, and we could actually go d over dx. We could take either one. We could either go dx over d, or we could also, and that looks like an A. Let's make it a little bit better looking. D. Or we could take the inverse cosine of fx over f. Either way, it doesn't matter. They should come out to the same thing. So I guess I decided to go with the latter, and I went negative 1060 divided by 2500, and I end up with 115.1. And again, it's negative, so you would expect something that was greater than 90 degrees. And then we have the cosine of, I'll write out the equations right now. Why not? I have the inverse cosine of 2120 and 2500. And just remember, by the way, it's the numerator should be smaller than the denominator, otherwise it won't work out. It'll give you an error, right? Because that means, because of course the hypotenuse has to be on the bottom, which is the magnitude, right? So you wouldn't want to get you wouldn't be able to find it. The hypotenuse is always bigger than the components. And lastly, for completeness, we got inverse cosine of, is this a negative? I think it should be, I'm looking up here. I think I messed up. Dumb. Maybe I should start over the whole thing, right? Yeah, because this was negative right here. Dummy. That should be negative, right? This is a negative 30. So that should be a negative. That should be a positive. And that should be positive, and that's positive, and that's a positive answer, right? And really, the truth is, we should just delete that part. So when we get down here, now I could even see that I did that. Maybe I'll double underline my mistake, because I did on accident, and then I fixed it, and now I've made the same mistake again. So anyway, don't be like me, kids. 795.0 divided by 2500. And we end up with 71.46 degrees. So the answers are theta x is 115 degrees, if I round down to 3 sig figs. Theta y is equal to 32.0 degrees. And theta z is equal to 71.5 degrees. Boom. And smiley face. Sticking his tongue out. Okay. The end. I'll make another video for 2.7, and I really should re-record this because I made that mistake in the beginning, but I'm hungry and it's lunchtime, so I'm just going to do it now.